that. And so then I made this cell. And so it was
now, by spacer material, you're referring to a piece of plastic that has grooves cut in it.
Yeah, basically, yeah.
To accommodate the stainless steel plates.
Mm-hmm. And
so
go ahead.
I'm sorry. So he sent you a piece of that material that he had in his machine shop in his home. He had cut grooves in it.
Right, and I guess they had switched designs on the 101 cell unit, and so he had just a bunch of this scrap laying around, and so I emailed and I asked and I received. So,
wow.
that before that, I was trying to figure out, well, how am I going to cut grooves in something, and so I was kind of stalled in my build because that's kind of a difficult problem to cut.
Well, we faced that problem when I had the Kentucky Water Fuel Museum open in Lexington, and went down and met Bob Boyce, and decided that we would do a replication of his 60 cell box at the museum. We went to a local machine shop, and they told me, "Well, you buy the end mill, and we'll mill it for you." And so I went out and got the little end mill. It cost about $13. And they attached it to their mill, and then they cut those grooves for me.
Mm-hmm.
But at that time there was no Ed Holgate cutting grooves for people,
Right. Yeah.
It's nice that we're that far advanced now.
Yeah, it's come along pretty amazingly. So I got that, and I bought my plexiglass, and I really hadn't built anything like that before, to be honest. I basically, I knew how to do solid modeling on the computer, and so I started out, I drew a solid model of this cell, my idea. And so then I had all the dimensions, how the real dimensions would work in a perfect environment. And then, basically the university already had a special plastic cutting blade for plexiglass. I had a lot of equipment that, would be fairly expensive for somebody to buy, and so basically the blade was made in such a way that it wouldn't melt the plastic, basically.
Right.
And so I cut out the plexiglass pieces and bought the special glue to glue it, and and glued it together and fired it up, and the thing put out way more gas than I was expecting.
Isn't that gratifying?
Yeah, it was really exciting.
Yeah, to realize that you, in your own amateur way, can produce an efficient device that turns this plentiful resource that's all around us into a combustible fuel really is pretty awesome.
And what's really exciting about it is when you measure the efficiencies on the cell, it's like you're pushing, probably in the higher levels of efficiency. I mean, you're probably in the 80-90% efficient, whereas a lot of those other cells, they're nowhere near that. And
yet what's amazing is that even at those lower efficiencies, they're still able to achieve positive results in using your existing electrical system to produce supplementary fuel.
Right.
That's the amazing thing, is that you don't have to achieve great efficiencies to see a difference.
Right. Well, I guess I look at it this way. I wanted to build the best that I could build, because I felt like, well, if I start out with the best thing that I can build, I'll have the best chance for success. That was my feeling.
Yeah.
So I built the cell, and then, it was basically, the car that I was using was a Toyota Camry, and nothing special, about it being a Toyota Camry, but just basically to get the car ready to be in a point where you actually can install a hydrogen booster. And doing it in the way that I was trying to do it, I installed a air-fuel ratio gauge, wideband sensor system, and exhaust gas temperature. I was trying to do it scientifically, basically. And so, to get to that point, it takes a lot of time. And so I'm like, man, I really want to do some testing. So one night I was just, I told my wife, well, I'm going to go over to the lab. I want to see what happens if I, mess with the scooter at the lab with the hydrogen. And so I took the scooter over there, and I'm like, well, I really didn't know what was going to happen. And so I pumped off the gas line and let the thing run out of gas, and then, had the cell rigged up to the the scooter, and it was all run out of gas, and just pressed the thing to start it, and it started up. And that was like one of the most exciting days. was to have this thing running off my cell, you know. And I just...
Now, this is, of course, up on a stand, not under load.
No, that's what I'm saying. It was powered off the wall. It was up on a stand. So it's not, you know, it's not drivable, but, you know, that's... At that time, there was really only one or two people who at least had posted YouTube videos that I could find running engines straight from their cells. I think it was the Smart Scarecrow and some other guy.
Yeah, and so to have achieved that, especially when you've got eggheads saying that you have to have so many hundreds of liters per minute of fuel to do this, they would have you believe that it can't be done on a couple liters per minute of output from a cell that you build yourself.
Well, I was able to idle the scooter down as low as probably a liter per minute. And then, you know, so then once I figured out, well, I can run this thing, you know, I got really excited about, you know, documenting it. So there's a lot of videos on my YouTube page of these tests. You know, I was just trying to figure out what the thing would do. The main thing was, like, after I could run it, then it was like, well, how do you know, rev the thing up? So I spent a lot of time trying to figure out how to get it to rev up. And there was a few times where I was able to rev the engine, you know, for 30 seconds or so. But when that happened, it was, you know, it had a lot of, it wasn't sluggish. It went right away. But it's basically, it's all an equipment issue. I mean,
yes.
If I had the proper, you know, the proper metering equipment to keep your air-fuel ratio right, I really think that you probably could run the engine fairly normally like that.
Yeah, it has to do with the metering of the fuel, the regulating of the fuel, and then the changing of the timing.
Mm-hmm. That was the interesting thing. I didn't need to change the timing. I don't know, you know, why on that particular scooter, but you know, it seemed to work without doing anything with the timing.
Yeah, but ideally,
I think every engine's different.
Uh-huh. Yeah, ideally you'd want to retard the timing so that the faster combustion of the hydroxy would not be fighting that before top dead center timing for combustion.
Right. Well, and that's what I originally thought. Well, this thing won't even run without adjusting the timing. But it did. And I do think, you know, for proper, if you really wanted to drive the scooter, like, you know, off of a system just off the cell, you know, you would probably need better control, more of a better control system. So basically, I was able to run the scooter and, you know, do the testing, but without any, without additional equipment and money. I kind of stopped that test because, you know, I really needed, you know, like a gas fuel carburetor and, you know, probably some kind of a timing control thing and some different things like that. So I kind of put that on hold, and then I was working with the car, and that's where the frustration comes, because I had the cell installed in the car, and it just seemed like you just weren't getting anywhere. And I experimented with the FE units and different things like this, and you would adjust the air-fuel ratio, and then it would fix it for you. So that's kind of where I'm at.
It was countering whatever you tried to do to show results.
And I don't know. I had the air-fuel ratio gauge hooked up on there, and it's not like, you know, when I had the cell on and off, I didn't really see a huge difference like that. So I don't know. I'm kind of a believer that the way you get your fuel economy gain is by leaning out the mixture. And that's how you get it. And I don't know for sure if the oxygen sensors are really negating what you're doing as far as the hydrogen affecting them directly. I just think it's basically the car is programmed to run at 14.7 to 1